We have been building the card game called War for the YByte Python curriculum available at www.ybyte.in. Previously, we have seen that both the players play their card, and we have seen how to handle a scenario where one of the cards is bigger than the other one, which is scenario 1A and 1B as defined earlier. Now here we are going to look at the third scenario, or say scenario 2 here, which is the case where both the cards are equal, in which case we have a war. Now when war happens, as we have seen previously, both the players are expected to contribute 3 cards. Now, before that can happen, we must make sure that there are sufficient cards with both the players. So that's exactly what we are going to do here. We are going to put an if-else condition, which means like a T-junction. So either I go here or I go here. I first check that both the players have sufficient number of cards or not. If they do not have sufficient number of cards, if either of them doesn't have sufficient number of cards, then I just say, okay, move is complete, game is complete. In fact, all I need to do is to say game is complete because that will be sufficient. That will break my outer loop. On the other hand, if the players do have sufficient number of cards, well, I can use the extend method to now take the player's top 3 cards and put them on the table cards, because that's what is going on. Remember, extend will do this item by item, which means that the number of cards that will move out from here will be 3, number of items that will increase in table cards will also be 3, and that will help me to keep count later on. I'll do the same thing for the compute cards, and of course, since I'm extending the table cards here, since these cards are being added to this list table card, I must delete them from the player card and the computer cards. Now this is extremely logical. Think about it. If you're playing this game in with real cards, you're going to take 3 cards in your hand and put them on the table cards. Hence, table cards will increase. The number of cards on table will increase, that is. But your own pile would have deleted these cards. And that's exactly what we are implementing over here. So let's see this in action before we discuss some parts about this. First thing first, I come into my if condition. Remember that was scenario 1A, scenario 1B. And the third scenario is a scenario which both the cards are equal. So I say, well, print war, say, begins. And when war begins, remember, both players must contribute 3 cards each. So both players must make sure that they have sufficient number of cards. I do that by saying, okay, look, if len of, say, player cards is, say, less than 4, or len of, say, computer cards is less than 4. Now notice here, I'm explicitly stating both the conditions because that's what I need to do. If either of these condition is true, I'm going to just set game complete is true, because that will basically mean that the game must get over. In fact, I'm also going to set move complete is equal to true, which I think is not really needed, but this is okay. On the other hand, if this condition is not true, so which means there are sufficient number of cards, I'm going to use the extend method for the table cards to say, okay, look, table cards dot extend, player cards, let's say, I can slice this and I say 0, 3, 1. Remember, start, stop, step. So when I put 3 as a stop, it's basically 0, 1, and 2. So top 3 cards of the player card, and that goes to the table card in 1 by 1 fashion, as we have seen before. And I'm going to copy this whole thing, and I'm going to say, instead of player card, use, say, compute cards. Basically from the player 3 cards, on the computer 3 cards. Now I must delete these cards from the relative, from the respective lists. So I go and say del, for example, player cards. Again, the same slicing function will serve me the what I'm looking for, and I'm going to say del compute cards. Let's say 0, 3 to 1. Now this is all very logical because these cards are being added to the table cards, and hence they must get deleted from the player and the computer cards. Now remember that this game is running in a sort of probabilistic manner, because we do not know what's going on. Sometimes player wins, sometimes computer wins. But when I want to test this code, that I want to deterministically create a war, I may have to, if I just don't do anything and just keep running this, perhaps I have to wait for a long time. But in order for me to test my code, I can play a simple trick just for testing. And what I'll do is that I will just disable the shuffling for now. And the reason this will make sure that the war happens is because, remember, I deal my cards in a very special manner. I take the first 26 cards for the player, next 26 cards for the computer, and that, since the cards are unshuffled now, it ensures that both of them pick the same card. Anyway, I'm going to ignore the suit. So let's see this now. When I run this code, I expect a war to happen right away. And indeed, a war happened. Now, this is very, very interesting. Remember, both of them put out a card to two of clubs, two of hearts. Now, remember, we are, when the war happens, we do a bunch of things. We basically look at the table cards. We expect the table cards to have been extended. And indeed, that is the case because C2 and H2 were put in the beginning. Both the players contributed three cards each. So C3, C4, C5, H3, H4, H5. That's why my length of table cards is right now 8. On the other hand, my player cards, for example, is going to start from C6. Remember, my player cards were earlier C2, C3, C4, C5. But these four have been contributed to the table cards. One from the first move and then the remaining three. And that's why I noticed that my player cards is, sort of the top cards have been removed. I can validate this by saying, okay, length of player cards, it should be 22 indeed, and length of, let's say, table cards is 8. And likewise, the length of, say, compute cards is 22. Now this was just to test. Obviously I don't want this to happen again and again, so I will just go and undo this so that whenever a war happens, indeed this will work the same way. So this is a pretty smart way to test it. Now before I wrap this up, there's a few points that I want to make. Number one, this function that we have used, this command that we have used called del, is in fact much like delete for lists in Scratch. Remember, we could say delete, let's say, one of player cards, delete two of player cards, whatever. Basically, that says go item one of player card deleted, go item two of player cards and delete it. Now, if I were to delete the top three items from a player card, I would have to put a repeat loop and delete one 3 times. Now, here, I want you to just pause for a moment and think, why do I not do delete one, delete two, delete three? Instead, why do I do repeat 3 times, delete one? That's something quite interesting. Now, as far as compare and contrast goes, del works much the same way, except that I'm able to do this in one command. I don't need to use a loop because I'm able to specify here, like a range in like slicing, right? Notice here, I'm not giving any step, so that step becomes 1. But, in my code, I wrote it as 0. I think I wrote it as 0, 3, 1, which is also exactly the same. So much like delete. One question that kind of came up in a discussion, so I thought I'll just touch on this a little bit. You remember, in the situation of war, we are saying that if length of cards is less than 4 for either player or the computer, then the game gets over. Now, a question that kind of came up is why 4, why not 3? Because the player and computer are both putting out only 3 cards. Now, the point here is this, right? If, let's say, either of players had exactly 3 cards, then they would have nothing left to play for after they have contributed their 3 cards to the table cards, which means that, the game is anyway going to get over. So, we can as well end the game even when they have exactly 3 cards, and which is why I put this as less than 4. Although I must add that we will in fact add some code later on which will still check for this condition. So which means that if you use 3 also, that will be okay. But just to be consistent with the previous parts of my, of the videos, I've made this 4, and I hope this idea is clear. Um, you know, I hope you found this interesting. I hope you found this enjoyable. If you think this way of learning works for you by building activities, by applying concepts to real things, look at our website because we have tons and tons of such activities. Take care. Thank you so much. Bye bye.